Okay, okay. Yeah, I guess. Guess I'm online. So, hello, Insta people. It's been a while. I guess I'm alone here, but I'm still going to record this one for the future. Yeah, it's been a while since I've used InstaMAT full time, so I want to get into it a little bit, and yeah, I'm gonna do so by making a simple generator. If you remember, or for those who have watched the other videos, I made some procedural cracks and some procedural stones, or like pebbles, and this is going to be very similar, but this time we are going to make a dent or a hole that you can then stamp as your height stamp onto your mesh in texturing. So, or like scatter it, if you will, uh, let's say in your procedural graph. So we are going to go through like two steps. First, I'm going to create a well, sort of a basic shape, and I want to try the nPass for this, which is essentially your repeat zone or your for loop from coding. And then we are going to take that and do some blurring, some warping, and maybe create some cracks to blend it with, and that's gonna be it. So hopefully I'll be able to make it because again, like I don't remember much from InstaMAT. I mean, I still use it, but I haven't done anything like this for a while. So uh, bear with me. Also, hopefully you like the intro. I was playing one night in DaVinci Fusion, and this is what I came up with. It's just an experiment. I'm not a video motion graphics artist or anything like that, so it has problems, like timing problems and spacing problems and all that. But I was just having fun, and I thought, why not, create a little intro and an outro at the end of the stream. There will be an outro. So yeah, let me see if I can actually take it down and start streaming my InstaMAT. Hmm. All right. Oh yeah, yeah. Sorry. Also, I would very much appreciate if you checked out my Gumroad page where I published a product for InstaMAT. It's a series of grunge nodes, 15 to be precise. So back in the day, like I don't know, half a year ago or something, I was just I didn't have much time, and so I like created a bunch of fast grunges uh, without really testing them in texturing or anything. But it turns out that it was like a actually a pretty good product, and yeah, you can get like 15 different maps or 14 plus some more. They are more or less production ready. They have a lot of parameters that you can adjust. And if you give me any comments, any feedback, any suggestions, I'll be more than happy to implement them. Also, thanks to Tomasz from Naughty Inward. He was my first customer ever, so thank you very much. And he also gave me a bunch of useful feedback, so I have already implemented some of it. He also gave me some tips on how to make, or not on how, but on what kind of grunges might be useful to make for InstaMAT. Also, just obviously, those are InstaMAT nodes, so you can use them in the element graph. You can also use them as assets in your texturing projects. So basically, what you get is not just like a single texture, but a bunch of textures, right? It depends on what kind of settings there are available for each grunge. Sometimes there are like 5 of them, and sometimes you can see that there are maybe 20 of them. So yeah, there's plenty. Mostly it's like scratches and some like hardcore noise and a little bit of like I don't know, splotches or moss or something like that, like moisture kind of grunges. Anyway, it's €2 on Gumroad, and I would be very much obliged if you tried it out. So that's that. Also, I have finally posted my portfolio, at least a part of the portfolio, of the final portfolio. This is a Behance page that I have. You can see that I also do more than InstaMAT. Yeah, I work in Blender quite often. So there are some motion graphic design, some environmental design, some abstract designs, obviously textures, InstaMAT textures, some sci-fi renders, some posters. So again, I would be very much obliged if you checked it out. So thank you very much, and let's get into InstaMAT. So yeah, here we are. I've already set up a basic nPass graph. So what nPass does, right? Like let's create a new one. So here, new nPass element graph, and so at the beginning you get these two nodes. You can't delete them. You have to use them. And so what happens, right? It sort of it's like a it's like a repeat zone from Blender, or sort of a recursive operation that sort of keeps looping X amount of times, right? And that's this setup here, like pass count. This is going to tell you how many times this whole thing that we are going to create here is going to execute. Now, you can do a lot with this. You can do, mathematical operations. You can do stuff with meshes and stuff like that. For now, we are just going to focus on a grayscale image generation, because that's what we need for our height map. And so for that, you need an image, right? An image. Imagine this as a canvas that we are going to put our strokes on, right? Like you're going to make a first stroke, that's iteration number 1. Then you're going to make another, that's going to be iteration number 2, etc., etc., etc. This is going to keep adding up into a single image. And that image, we are just going to call it a buffer image. And so for that, you're gonna have to create a variable, basically something that the ngraph knows how to work with. So for that, we are just going to say add local variable here and create an image grayscale, right? So you can see that we have created a new input here. And so what we need to do to be able to do something to it, to this variable, first of all, let's name it like buffer image. Yeah. And to do that, we just have to drag it here. And here you can see that we have this nPass variable here. Now, internally, this is a black background object, right? Like a zero value, basically solid color object, no data. Well, we can use something like a blend, right? Let's say this is going to be our background. And for this graph, I want to start with something like maybe a triangle or a polygon that's going to define the base shape of our hole. And I want to create a bunch of them, because a single triangle is not an interesting hole, right? Like I want maybe 6, 7 triangles overlapping. Maybe we can do some random transformations to them. We can do some blurring and stuff like that for each shape separately on each iteration, right? So what's going to happen if I add a triangle here? We are working in grayscale, so let's do that. And we plug it in. You can see that before we just had a background, the empty background, and the foreground was this icon, this InstaMAT icon. Now we are basically inputting a triangle. Now, this is just a normal blend operation, right? Like nothing is looping yet. Oh, hello, Capzor. How you doing, eh? I think you're first time on my stream, right? Well, welcome, welcome. If you have any questions, feel free to communicate them. If I know, I'll answer, obviously. Anyway, where was I? Yes. So right now we have just blended something, right? Like we haven't done any operation, and most importantly, we haven't output anything, and we haven't saved anything for the next loop, for the next iteration. So normally, in a normal element graph, what you would do, you would say expose as output, right? And we do this here as well, but this is going to be our very final image. We still want to go back to what we are doing here, and to do that, we have to output this state of the loop before we export it as a final image, right? So what's going to happen? Now let's forget about this on start for the time being. So the first iteration number 1, is going to take this empty background, right? This black background, and it's going to blend it with this triangle, right? It's iteration 0 or 1, if you will. I think it's going to say 1. sorry, pass index is 0 because it's an index. You know, in IT we usually count the indices from 0, but it's we have done one iteration, right? Now let's say we do this twice. Right now we don't see anything because the shape is exactly the same, so it's basically like adding it up or like rewriting this. We should also say add, right? Um, but let's say we change the, let's just do some rotation, right? Like let me expose that, expose input parameter, and we want a, actually we want a random number, random value, what's it called? Random float? Random, what's it called? The random number float, yeah, that's it. And so the, what is it? Is this 360? Yeah, I think it's 360. So we are going to say a minimum of 0 to a maximum of 360. And we want to randomize this per iteration, right? Per loop. Every time we execute the operation, we want this number and this value to change. So to do that, we need a, what's it called? We could use the pass count, I suppose. Yeah, let's use the pass count, right? So we plug it into this seed number. And so every time we change this, it should... Oh, I haven't plugged it in, yes. Ha, okay. So now we have done 2 passes, and it rotated the triangle, but it should be adding it. So let me just see what I'm missing, huh? Think. Okay, maybe 3, 4. Or maybe it's not the pass count, but the pass index. I always confuse these two. It's like the naming is a bit strange. Ah, yeah, you can see what it does right now. On the left, you can see that we have now added 59 differently rotated triangles, which is not exactly what we want, right? Did it work with this? No, it didn't. So we need to use the pass index, I guess. So we don't want 59, let's say 5. Yeah, and so you can see, the preview here is a bit funny, but you can see here that the buffer image has stored all these iterations onto itself with the add blending mode. So we have always like added a triangle, then another rotation, another iteration. We have changed the rotation randomly and added a different triangle, blended it in, it saved it, then we went back, we created a random number again, then we rotated the triangle again, then we saved it to with the triangles that we had before, etc., etc. Once this happens 5 times, it's going to output the final image, right? So that's the essential idea behind these looping nPass graphs. Why it's called nPass? Well, because it does n amount of passes, n number of passes, with the operation that you specify here. Obviously, this is like probably the simplest possible operation you can do. You're just stacking images. But you know, people have been doing some crazy stuff with that. I have an idea. I think we could make L systems with this. I still haven't figured out how best to approach it. It might be better to do it in the atom graph, and that might be a bit difficult for me. But yeah, essentially you can. I don't know. You can. I've made a few notes. Actually, I can show you. For example, this one. This one takes an image and creates an array. I don't know if you can see it here, but you can take an image and basically I created it so I made it so that it sort of creates an equal distance between each object, no matter how many of them you add. So you can have like 11, let's say InstaMAT logos, not right now they're overlapping, but it will automatically calculate how much it has to scale them down, right? So that's one. Another one could be, what's it called? I think I called it Ringify, which is essentially it's going like it's doing like a edge detect situation here, and it adds it up because I always scale the image a little bit, or like I do a bevel or something. Yeah, a distance here, and then I do the edge detect, and so I create this like outline effect, which is very cool for some more graphical applications. Now, I want to talk about these two nodes because in the previous version, They were called onExecute and didExecute, which wasn't very descriptive. I think a lot of people did not understand that. Right now it's a bit better because it's called onStart and onIterationFinished. So we've been using the onIterationFinished only, yeah, and that's so that's obvious, right? Like the iteration, the operation runs through, and something happens here, something gets saved here, right? Something changes here. You can save numbers, you can save anything that InstaMAT can handle here, right? On start means that it's sort of like a preloads a certain state only once, right? So I could maybe input a black background here once, or I could input, I don't know, some other color, and then it would just execute the operation once at the beginning, at the very first loop, before the very first loop actually, and that would be it, right? It's like loading in an input basically. You can also do that, right? Like we could be I don't know, inputting something here, like an input that you can expose to the user, obviously. But right now we don't need that. So as I understand it, this might have some uses, but right now we don't really need to be concerned with it. So yeah, so we just want to do something here so that we can create a nice basic shape for our hole, and then we are going to take this as a generator, put it into a normal element graph, and transform it with different noises and warps and whatever to create sort of hopefully a good looking alpha stamp that you can then use. So so first of all, right, like I've already showed you like what the workflow is going to be. We are just going to create a bunch of random triangles. So now the task is easy. We just have to expose a lot of parameters here and specify how large the triangles are going to be, how much they can rotate, how soft they are going to be, and that's it basically, right? Maybe we can like flip them randomly. We can do that. So I think for the most part we are just going to play with this what I'm saying, with this transform node, which is like an inbuilt. So what I took is this is called a shape generator node, and it has a bunch of possible shapes you can have here. They all have some kind of parameters that you can play with, and it always has an inbuilt transform node. So we could do this ourselves, right? Like we could just add a transform here, and yeah, that would be it, right? Like we would have the same parameters available, but yeah, we don't need that. Anyway, so yes, I think the rotation by 360 degrees is fine, right? So that's one. What else are we going to be needing? So I think we are going to need to randomize maybe the softness, right? We also, actually we can do it better. We can do expose input parameters and scroll through here. Maybe scale, maybe translate. I don't know if mirroring is necessary because we are just like rotating a a triangle that's more or less what's it called, equidistant, equirectangular. No, not equirectangular. That's bullshit. I don't know English, you know. But you understand, right? Like we are just like rotating a very simple triangle and blending it together. So I think that's it's gonna be perfectly fine like this. Anything else? Shape clip, resolution. I think for now this is going to be fine. The rest is like UV transforms, which we don't need to be concerned with, or we need to bother with. So yeah, so we do these. I mean, I'm exposing it. We are not going to be using these values exactly. I just wanted to see what data type they are, right? So this is a float number, basically your decimal point number, and these are vectors, right? Like obviously you know what a vector is, but just in case you don't, it's just like a number that contains two numbers, right? Describing in this case the x and y location and the x and y scale of our shape. So what we are going to need is another random float here, but you can see that we have, because we are driving it by the pass index, the number here is the same because the seed is the same. So I think we will have to find a way to randomize this. I really wonder if the pass count can do that. But, yeah, we can always like create another random number generator here. But yeah, so that's going to be our softness. And that softness goes from 0 to 1, I think. But we probably don't want it to be like that soft, right? So we are going to say, I don't know. I mean, it's okay, right? Like it's gonna be an interesting hole once we start like blurring it and adding it together. So I think it's probably fine. Maybe we can like expose it to the we can expose it to the user to specify how much softness he wants. So Capsor, why does pass count not work? Yeah, I'm always a bit confused about this. So we have this pass index and pass count. I think pass count just says how many times the whole loop iterates. But it's like a single. I don't know. It should work, right? It should be the exact same as the pass index. So output. Why does pass count not work? Output random number always less than 1 when pass count is used. Which is strange if 5 is used as seed. I'm not exactly sure what you mean. I think, okay, I don't know. I actually don't know what the difference is. I think, I think the difference is simply, actually, can we see the value here somewhere? Like, does it give us the value? No. Can we assign, what is this type? Assign new integer. Okay, so this gives, yeah. So I think the difference is just that the pass count says how many times it executes, and the index is the same idea, but it's shifted by 1 because it's the index, right? So if we have, I don't know if I can, yeah, it's definitely the same seed each iteration. Yes, yes, exactly. Yeah, that's exactly it, right, Capsor? So because this number drives the seed, the resulting number for any kind of random number generator is going to be the same because it's based on this. We need to find a way to change that. So what I would do actually is just do u integer plus u integer, and like maybe every pass index we can add 1, or we can add the pass index and the pass count, right? And yeah, actually we should do yeah. And so if we do 7, it's going to be 7, right? And pass index on the 7 is 6. Yeah, yeah, that's exactly it. So what we need is to, well, simply I think we need to add them every time. Yeah, exactly. So yes, the pass count is how many times you tell the system, you tell the the nPass that it has to execute that amount of time, whereas the index tells you, well, it basically tells you which pass you're on, right? But it counts from 0 instead of from 1. Right, pass count is always, if you do 0, it won't execute at all. If you do 1, it will give you exactly 1 triangle, right? And the index is now 0. You can see that, right? So we have a pass count that's 1, and the pass index is 0. If I increase this to 2, it's going to be 1, etc., etc. So it's the difference between trailing and what's the other one? You know, in Blender, if you use Blender, there is this trailing and leading, I think, leading count, and that's it. Now I just have to figure out how to randomize this number for every randomizer. Maybe we don't have to put in any seed here. It's going to be driven by this then. I'll have to test that. Hopefully I've made it clear. Sorry if I'm not the best at explaining this stuff. I'm not a very good logician or anything. Pass count should be called passes to perform. Yeah, yeah, yeah. It still feels like we are counting something that has elapsed, right? Instead of like how many we are telling it to do. Yeah, yeah. I agree. It's maybe not the best naming, but once you know the difference, you know it, right? Like that's the thing. Uh, what else would we call it? Like pass. I don't know. I don't know. Anyhow, let's focus on our little generator. So we can leave the randomization seed for later, maybe. You're just going to take the let's use the pass count for here for now. Huh? And yeah, so we have a certain rotation, we have a certain softness. Now we need to create our two vectors. So we need, how should we do this? Maybe it would be good to create a vector 4, which is this one, if I'm not mistaken. No, that's the other way. Vector 4. What's it called? I always forget the naming. Make vector 4, which is going to give us 4 numbers, and we split it into 2. Is that possible? Might be easier to just create a random number vector 4, vector 2, I mean. Yeah, it's probably easier to do this. We are going to do this twice. And so the scale, right, like by how much? Well, let's say the smallest one should be like, I don't know, 0.2 and 0.2, and the maximum of like I don't know, 7 and 0.7, and that's what we plug here. So now now they are going to be smaller, which is what we want, because we want them like in the middle, right? That's where the hole is going to be. And we also want to translate. Now, I guess we are going to move it a little bit so that it's like but we don't want it to go like off the edge, right? Like we don't want it to tile it or anything. We just want a single stamp in the middle. So how do we do that? Well, we just control the values a little bit, right? So we say minus, I don't know, minus 0.2 and minus 0.2 and 0.2 here and there, and that should, like, yeah, move it a little bit. So now let's see if we have what we need. Pass count. Oh, we still have, yeah, we need to use the index. I'm stupid. Now it works, right? Yeah, I guess the pass count is always a single value, whereas the index changes over time. I think that's the main difference, right? Like, this actually is more like an array, and this is just a single value, even though it says like it's it's a single integer, right? But this is actually a field. Are you making something like bullet hole in metal? Yeah, kinda. Basically like your impact hole, right? Like nothing too complex. Just because. Okay, so I should probably mention this. So InstaMAT has these nodes in them. It's called Dents and holes. And you can see it's like a very simple graph, right? Like you have some shapes, then they get distorted, they get warped, they get blurred, and in the end you're left with something like this. And then you can use this as a brush, for example, and subtract it from your height in your layering project, and that's going to give you a dented look, right? The same goes for holes. So the issue I have with this is that you only get like 3 variations, right? Like 3 versions. So for example, here a person drew this shape using a Bezier curve, which is not exactly procedural for me, right? Like not procedural enough. You get a nice shape, but what if I want another shape, right? Like I have to like go in and draw my own shape and create another Bezier curve? Well, that's not exactly procedural. So while this is awesome and I've used it, I've recently used it in a project of mine. Um, I wanted to do something maybe a little more procedural, right? So the idea is going to be this is a project. This you can find it on my Polyverse actually. This is a simple generator where I drew some curves, then I randomly scale them and rotate them, then I do some warping to them, and in the end we are left with some cracks that you can then use in your projects, right? And because this is entirely procedural, almost entirely procedural, you can just click the seed button and you will get new cracks every time, and you can play with that. So this is a similar idea. I want to do something like that. Okay. Yes. Yes. We did that. We did that. Yeah. Okay. Where are we? This is just the experiment from before. Yeah. All right. So we should get on with it. Right now, it seems to me that it's like getting pushed. I think the one issue there might be that it like remembers this number. I don't know. Oh, no, because no, we haven't plugged this in. Ah, okay. So, but I think this is too much. The range here is too much for the translation. So we are going to say like that. And maybe the scale is also a bit too much. So like 0.35. I don't know, 0.9. Yeah, that should be good. And also the softness is probably way too much. So we should maybe start exposing these. So rotation, I don't know. I think rotation can stay the same more or less, but let's expose it anyway. So input here, input parameters. We want the maximum. Here we want both of those, which is this and this. Yes, and we are going to want this one as well. Right. So now we have these parameters here that we can tweak as we go, and also this is also going to be visible, or this is going to be available to the user. So you can you can change it later in the graph. So we should just name it a little bit. So we can delete the old ones. And so this one is the maximum rotation. Okay, so rotation, I don't know, rotation. And we say, that's fine. This right here is what? This is the softness. We should also make it the range actually. So expose input parameters. Okay. Right. So this is the minimum. This is going to be softness, min, softness, max. Here, this is what? This is the scale. So this is scale minimum, scale min, scale max. This is the offset, offset min, offset max. Okay. And I forgot to say change this. Okay. Now we can actually look this, and we can look this. Maximum softness maybe I don't know, 75. Minimum softness 0.1. And it's too big. Okay, 0.8. All right, let's see if we can play with this and see how often it goes of the, yeah, it's still a bit like large, and it seems to like go in one direction, doesn't it? Right? Like it seems to be, I don't know if that's because of we use the same pass index every time. Maybe we could do, what can we do? What happens if I just don't use this? Oh, it becomes stacked. Yeah, yeah, sure. So how about we do add plus here, and we just add some random number, like 1, like more, like 666, and we just use that for this. We can do that again, and this time we will do 6000. Might be a problem because it's going to start clipping. Not sure. And I don't know, we can subtract 6000, and we can so do this, right? Like, I don't know. It's too much. Let's just do it's a small number. I don't know if that helped. Yeah, it helped because now it's like a different number every time instead of the same number for all of them. But does that even help? Did I do anything? I'm sorry, my brain is fried. I guess I didn't really change anything, right? Because okay, it's a different seed for each number, which is fine. It's not the same one, but it doesn't really matter. It's still going to do whatever it was doing before. That was pointless. Um, what we could do is before we export this, we're just going to transform this one, and actually we can do this. No, we can't do this. We can do this, and we are just going to say scale it by something, right? Like the scale is going to be 0.8. It's always going to be a bit smaller. Yeah, that'll work. We don't need this one. Right. Okay, so that's the base, I guess. We still need to work a little bit on the actual shape. I wonder if we could, or if we should, maybe squeeze the triangles a little bit so that they are more, well, flatter. Can we actually use another one? Like, these might be a bit better if we make them larger. So for example, we could make them just one. And let's see. Yeah. I mean, sometimes it seems to like create something at the edge. I don't know how that happens. Is that just an artifact? Maybe just an artifact. And so maybe make this a bit bigger. Where is this one coming from? I have no idea where this one came from. Oh, because that's because we are scaling it and I forgot to say now. Okay. I'm just a tiny bit stupid. It's not that bad. Yeah, because so we transform it, we scale the whole thing down and I try to make it tile, right? So if we set the transform to wrap, it's not going to, well, it basically turns off the tiling, right? So that's that. And I think this could be a like a good basic shape, I suppose. I wonder if we could also do more. We could, for example, we could actually have the user choose which shape they want to do. The issue with that might be that some shapes won't have all these settings. I think the transform settings are okay. They are not a problem. What might be a problem is the roundness and the softness. Oh, sorry, the softness. Mostly the softness. I don't know. Let's see. Let's see. Do we get? I guess everything has a softness parameter as well. So yeah, we can let the user choose what shape his hole is going to be before all the blurring and stuff. Okay. All right. So that's another setting we can do. And what else? We might want to randomize the color. I don't know. I mean, why not, right? Why not? So, actually, we could even like randomize this, and like the hole would then be created by a random selection of all these shapes, which would be total chaos, I guess. But why not? How does one do that? I think we have to extract the sort of the number of the on this list and choose from that. Do I remember how to do that? I did. I've done it a couple of times before, but how does it work? I think it's the enum converter. Yeah, so we can randomize this and then plug this here. So how many inputs do we have here? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, so we go for random number unit integer. And how many how many did I say there were? Was it 23? Was it? I don't know. We'll find out. 23. Question is whether it counts from 0 or 1. I think it's 1 here. It doesn't do an index. It's like that. And then we can plug it here. Yes. No. It always... Oh, yeah, because we are not changing that with the seed. So now... that's a horrible thing to do. Well, it was an interesting idea. Let's not do that. Yep. So, well, okay. We could randomize the color a little bit. How do we do that? I don't know if it looks cool because, you know, it would be total chaos with all the blurring and warping and stuff we are going to do later. So it's probably not a good idea. Like, that's a complete mess. I mean, you know, okay, so since this is more like an exploratory stream, what we can do is to do a switch. What's it called? The conditional select. Conditional select, and is it string or enum? Resource, point cloud, integer, boolean, and I don't know how to do this. Maybe material conditional select. I'm always confused about like what this is, what kind of data type this is. So if we go here and we see showing variable editor, what's it called? Type enum value. Enum value. Get enum value alpha blending. What the hell? Blending type. Yeah, sure. I'll get there. Anyhow, I think there is a node that, for example, you get an enum select boolean, and you can have like a switch between the values you input here. So, for example, if the value here equals something, then it will say true and output the value. So that's that, but we do not want to do that here. All right, I think basically this is it for like the basic shape generation, right? Like we can keep it like this for now. I'm just gonna name it like DKNS, I don't know, nPass, what, hole base 01, right? And I'm gonna give it a tag DKNS nPass like this. And it's just like a hole generator. All right, this. I'm also gonna sign it because I'm an egomaniac. DKNS sign. That's it, and we can save that. I can't type shit. All right, and that's it. All right, so ignore that. Those were just some experiments that didn't work out. Now, since we saved it, it's now here, right? Yeah, exactly. Whole base 01 Ultra Platinum Extreme Plus, you know? That's how my naming goes. Alright, so we save this, and we can just drag and drop it, and you can see that this generates a hole for us. We even have the seat number, so we have the shape here. Yeah? Which is good. So, let's pick something that's a bit sane. We should really undo that and just use triangles or polygons or whatever, but that's fine. I think 5 iterations for now, that's also fine, and let's just explore what our little developers in InstaMAT did. Well, for the dents, it seems to be very simple. It's just warp. Warp and blur, yeah? And we get this, but that's just the dent, right? For the holes, it's a bit more complex, so we get this blur, some resampling, that's okay. Blending. Okay, the first warp is like with clouds, then it's some beveling, another, this time crystal noise, of course. Then we get non-uniform blurs to create a bit of variation. Anti-aliasing. They subtracted the blurred image, so as to create this like gradient, I guess. And that's it. That's it. I think we can do a bit better, maybe. We'll see. What else is here? So here we have another shape. It's blurred or like distorted with Perlin noise. Again, bevel. Again, some blurring. More Perlin distortion. Okay, and that's it. Yes. Enum select image. So it's conditional enum select image, I guess. That's what we needed to do before, but it's fine. All right. So let's see what we can do. So first of all, I guess I would like to. I mean, we were using pure white. I'm just gonna make one last change here, and I'm going to randomize the color here. So we are going to say that our triangle here, I guess, right? Yeah. So we are going to expose that, and oh, it's an image, not color. How do I change that? Oh, no, it's no, it's not. Is it? I guess it works like a mask. So we do solid color. We take this as a foreground. We put this to 1. Yeah, that's it. So we expose the luminance, and we say that the sorry, not like this. Being stupid. I want what I want. I want the random float here. Okay, we also get this. We plug it here. We just like, I don't know if that's necessary. Actually, it isn't, but it doesn't matter. And the maximum here is going to be 1, and the minimum is going to be like 0.7 again. And we can hover and plug it into luminance. And now with every, and also we said add, maybe we should say maximum. Does that make sense? No? 0.71. 97? What? Oh. Oh. Okay, we need to divide this. So that's divide. Flow divide by 10. 100 lumens. Ah, that's it. Yeah, because we don't want the value to be 100. White is 1, so we want this to be in. I guess we could. Well, this is fine. We've divided it. That's fine. Okay, so now we have randomized the value as well, and the brightness value. And we can save this, and it should now give us this luminance as well, which is great. Let's delete these. Pass count, we don't need pass. No, we need pass count. What am I missing? Why am I not seeing this? Shit. Oh no, I'm sorry guys. I'm really tired. So I guess we were feeding in 360 from the rotation instead of this. So now we expose this as a I don't know, luminance max and luminance min. All right, now I'm happy, more or less. And now we don't need to do this thing. Yeah. All right. So what do we want to do? I guess we are going to be blurring it first of all. So let's do a bit of a blur just to bring it all together. I don't know, like so. Then I guess we can do some auto leveling just to be sure that we have the whole range. It probably won't be much of a difference. Then we could start doing some variations, right? So let's get a, I don't know, a warp. Let's start with the normal warp. And probably use something like Berlin, maybe. Yeah, let's start soft with like the soft shapes. So let's get a Berlin noise and let's tweak it. So the intensity. Okay, and then focus. Yes, that's it. I mean, I don't know what looks like a hole and what doesn't, right? I guess this is fine for like an impact thing. Of course, this is not our final shape by any means, so that's fine. Maybe we could even go lower. Yeah, I think I'm happy with 7. Now we should probably. So this was like the very basic distortion. We could do. What we could do now is we could. What do we do now? We could. I guess we could warp it some more. Let's use directional warp. And for that, we are going to do maybe crystals. Crystals. Which one? Probably this. Okay. I mean, does it matter? Probably not. Alternative default. Okay. Oop. And this is way too much. Okay. Maybe we are going to do 4 directions and we are going to set it to either chaining or maximum. I'm gonna say maximum maybe, but this is not the best. Can we have something less sharp maybe? I guess Euclidean is probably the best here. So you can see it starts creating a little bit of like indentation here and there. I may have to blur this a little bit, or maybe change the phase a little bit, which is going to give you like more holes in your distortion, more pronounced transitions. Then we can do a bit of gamma adjustment. It really like doesn't matter. In fact, we could again like randomize this, right? Like we could say we could plug a random numbers generator into the gamma, and every time we create a hole, it's going to be slightly different. I don't know if that's a great thing to do because it reduces the predictability of the results of your nodes. And so let's say right now I'm just doing it for the kicks and for the stream. But let's say I wanted to sell this or give it to some colleague or something like that. It's probably not a good idea to just like randomize everything there. You know what I'm saying? If you press a single button and everything is completely different, then you haven't done your job as a technical artist or like a material artist. So there's that. All right, let's run with this. Why not? But also go minimum and sort of like create I don't know, well, different kinds of indents really. Maximum, minimum might be better. Average is boring. Chaining. I'm gonna go with minimum and maybe increase the intensity a little bit. Okay, so now we are getting like some sharper shapes. I like that. I like that. So let's do this again, maybe another directional warp. Where's the warp? Let's just copy it. And this time we use something with more of a frequency, like let's not do like very small details, very high frequency details yet, because we are what I'm planning to do next is to maybe use the bevel or slow blur, and after that I want to distort it with like this very subtle, or no, maybe not subtle, but very sharp small details, right? Like let's say your stone noise or your fractal sum, which is going to be great for this, right? Fractal sum, maybe something like, no, that's not the one I wanted to click. Fractal sum, maybe the simplex or the sloped is usually pretty good for that, right? Like if you check this out, this is pretty much a stony pattern, and if you use that for your slow blurs and warps and what have you, it's gonna give you more sort of believable result. And it's also a very high frequency noise. You can see that there's a lot of details and a lot of transitions between the blacks and whites, and that's going to give you like quite a bit of an effect. We'll get there. I'll just keep it here for the time being. So what should we do? Maybe we could do like another crystals. I'm thinking maybe turbulent purlin, but that might be to maybe clouds. Do we have like clouds? Cloud spots. That's a new one actually. In the newest version of InstaMAT. I'm just gonna go with crystals again. Why not? Yeah, this one. And let's do the face again, I think. But let's increase it to like, I don't know, like so maybe 17, 18, something like that. Euclidean is fine, and we are going to plug it in. Oops. And that's too much, obviously. Let's do that again, and let's set it to, I don't know, maximum for kicks. Yeah, now you can see that it's like giving me these very sharp edges almost. It's very likely going to be too much, but I guess it's fine. We can always blur it out a little bit, yeah? So that's that. Let me just save it quickly and let's get inspired. So what did they do here? Some simplex blurring, that's fine. Oh, that's just a crack. Crystals noise to shape generator simplex. What is he doing here? Interesting. Interesting, very interesting. Yeah. And the holes. Yeah, he's using, you can see here, right, like this is the shape that he drew, pretty much, blended with this star. and then he uses clouds directional warp to sort of introduce this very fine detail. I think we are not there yet. Crystal's noise, this is a pretty large one actually. Oh, because he's non-uniform blurring it. Okay, that's fine. So the non-uniform blur is going to, well, blur your input image, which in this case is the bevel, by another grayscale image, and it's going to be non-uniform. So some parts of the map are going to get blurred more. That's where it's white, and the black ones won't get blurred. So basically, what he's doing, he's sort of like blurring the interior more than the exterior, right? Because this map here has these like white parts here and the grays here. That's where the effect is going to take place, because that's the intensity input. All right, but I guess I have seen what they do. So what do we do here? Let's try something. Let's say bevel. And maybe we want grayscale. Okay. Outward. Ooh. Okay, that's a thing, but maybe not what I wanted. Softness. Less. I think the issue with randomizing the color beforehand is precisely this, because the bevel works best if you have black and white mask or black and white image. So if we did this grayscale to mask, which basically is your, what was it called in Substance Designer, your histogram, I don't know, is it select? I don't remember. Yeah, so you get this grayscale to mask, and which has some inputs here. You can like basically it clips. It's a threshold mask. If you know this from Photoshop, maybe it's a threshold mask. So maybe we don't want to lose any detail, or maybe we do, right? It's up to us. I think maybe a little bit, because it creates these interesting details here. And now we can bevel it, right? And why is it giving me colored height? That's okay. That's a bug. That's definitely a bug. Okay, invert. That's fine, but we don't want to do it too much. Okay. I wonder if we could still like maintain some of the detail. So let's do some blending here. And let's say, what, average? I mean, it's not the worst. I wonder if we go for something crazier like difference, but it's not going to work here, I think. Overlay, soft light. Soft light might be the best actually for this. Yeah, difference is not going to work. Maybe exclusion. Just a little bit. Swap it. It's going to flatten it very much. Well, that's also an interesting effect. Let's say you wanted some outline. Yeah, like exclusion, difference. Those are like pretty good blending modes for that. Negation is also very good. It tends to create these sort of electric ridges. I use that for crazy effects sometimes. Anyhow, I'm not too fond of the bevel route. We can use that later if we want to, but for now, let's keep going here. Again, and are we still auto-leveled? I guess we are. So let's do some slow blurring, maybe? Slow blur. Oh, we've lost a lot of detail, but that depends on the kind of noise you use. Right now it's using this default noise, which is basically your purlin. Yeah, this is essentially purlin. So we want to use something medium to high frequency here. And I'm thinking, what am I thinking? Let's just type noise. Maybe this ridge noise, which is essentially like very similar to crystals. It might be useful. What else is there? Maybe you should use clouds or some kind of reckless sum. Wavelet. Yeah, let's just use clouds and let's go for something like clouds heavy maybe. Clouds heavy. Right. Let's preview this. So first of all, I think it's way too nice. Frequency smooth. Yeah, I want it quite sharp. Frequency gain. I think I want the gain up so that we create these like harsh transitions. Maybe I can even level it out. Clip, basically create more contrast, right? Oops. Yeah. Yeah, that's what I'm going for. Height. And we need to tone this down heavily. 4. And let's do like 5%. Yeah. Okay. And maybe blur it by like 1, 2, 4, 5, 10 here. Okay, that might be too big there, so we do 10%, 5% blur, and let's do 5 here. 6, 5. Let's go 5. Okay. I think we can maybe do, like we could blend these two shapes together using a dissolve blend, which is a very simple node. It takes the foreground and the background and blends them together using a very basic noise. Again, like a Berlin noise, I think. Yeah, you can choose Berlin, Warren noise, cellular, even stone noise that I showed you before. Yeah, so now we go dissolve. I should show you what it does. Okay, dissolve. Yeah, you can see like the two images are blending a little bit. This is a low cost, like relatively low cost node, so I like to use it for these kinds of like details, I guess. Now I'm thinking like the mid-level and the sort of high-level, mid-level details are like the low frequency and middle frequency details are kind of there. It's not the best. For example, what I might do is to blend in or use some kind of warp or something with the terrace noise, which is one of my favorites for this kind of like layered effect, which the holes can be, right? Especially if you hit something like maybe not metal, but if you hit if you have an impact into your concrete or stone, it tends to create these like layers of as the vibrations continue through the stone, it sort of creates a layered effect. I don't know if I'm explaining this well. So terrace noise for that, very good. Here we have that, and so like low level details, right? Let's sorry, high frequency details. I can't really. I shouldn't have streamed, but that's fine. Let's do direction warp maybe. And let's use stone noise. Let's use stone noise. Boom. Oh yeah. Oh yeah. Oh yeah. Oh yeah. That's it. Directions maybe again 4, and this time we go minimum. Yes. Yeah. It's sort of eating into it, right? Because it's only maintaining the blacks from both of the images, from the warped and unwarped image. It might be a bit too distorted, so either lower the frequency here, let's say to 2. By then it's like this. Okay, that's bullshit. Oh, because it's not locked. Okay, 2. Frequency gain. Frequency slopeness. Maybe it's not the best. Maybe we use clouds. Again, clouds heavy. Like so. Yes, that's going to be better. Lower the intensity. Okay. Okay. Fine. Let's just try a few iterations. Huh. I mean, it's something. It doesn't really look like a hole. This one does. This one could be good. This one really doesn't. This one does. Oh. I think it mostly comes down to the to the initial shape, right? Like if you have something crazy like a, I don't know, like a circle or something in there, it's maybe not the best idea. But it seems like most of them are fairly usable, usable. I don't know. Now, okay, what I'm going to do now is actually use some non-uniform blur because I don't want to have this kind of detail everywhere. It feels a bit more like some watercolor or something. So let's do non-uniform blur and use something. It doesn't really matter. Let's just use the Berlin again, like so. And the intensity needs to go down. Maybe this is too. Yeah, and the intensity low. So before, after. I don't know how much you can see it on the stream. I guess you can, right? Like it blurred these super weird edges there. I might do just a normal blur again because it's height and too sharp height, height transitions are not the best. So maybe like 1-2% to just get rid of the, yeah. It's better. All right, so I think that could be like a basic hole setup. So what we could do now is maybe just do an invert. Yeah. So this is the shape. What the InstaMAT guys did, they always do this kind of operation, right? Like they have the base shape, and they blur it at the beginning and then subtract it, so it creates a sort of an outline, I guess, a gradient transition. Yeah, and this is the result. So you can see there is a bit of a gradient there. I guess we could do that as well, but for now I think this is fine. Now we need to, so let's actually do height to normal to see what we have created. Yeah. Aha. So, immediately it's obvious that it's maybe too noisy. And also, like, this kind of flat area, that's no good, right? That's an area without any detail. So one obvious thing to do would be to multiply in beforehand, to multiply in some noise. So maybe we can do the stone noise or the sloped fractal or whatever. Let's just do a blend. This is going to be a background. This is going to be our foreground. And we can do like multiply, right? But it's too noisy. Not great. Yeah. Maybe do it before the blur. What am I doing? I don't know what I'm doing. Yeah. It's a bit better, but you can still see that it's just noise, right? So this is something to figure out, to work on some more. This probably needs a mask so that it's like not as uniform. So if I just take this Berlin again, you can see that it's sort of like you still get like some breakup there. Or we could use I don't know, minimum. Maybe it doesn't change much. Minimum is essentially your darken from Photoshop and other programs. It just takes the lowest value of the two images, right? It's very similar to multiply, but of course multiply multiplies the two values. So if you get 0 times 1, it's still 0. If you get 1 times 1, it's still 1, right? But minimum will take the like actual lowest value from the two. It's like a compare operation. Okay, so I think as a demonstration, right, what you can do with the nPass, which we created here, we are basically just creating a very simple scatter node. It's not the most optimal way. nPass graphs are usually very performance heavy, right, because you're sort of processing the image over and over again instead of just doing some parallel operation on your GPU, which is what the atom graph is for. But I'm not able to use that yet, so simply using this simple nPass. Now let's open it again, so just to see what we did. Well, we basically took a shape generator. Originally we started with a triangle, right? But right now we are doing something crazy. We are randomizing the shapes like this. Basically all the shapes that the generator offers are getting added randomly. We've randomized the position slightly, we've randomized the color slightly, the rotation, the scale, and that's it. Then we are basically iterating through it. So we have this buffer image, which is just a black background at the beginning. And on the first iteration, we add this shape. Then on the next iteration, this changes, right? And we add another shape, different with all the different parameters randomized. That gets saved in this node on iteration finish every time. And once we iterate how many times? 5 times. Once we add 5 different shapes, it goes through. We scale it down a little bit, and we output that. This output is this node right here, which has all the parameters we've exposed in the previous graph. So we can change the the ranges for our randomization, and yeah, then we are doing some warping, distortions, blurring, and stuff like that. I'm not saying this is a perfect product or anything. I wouldn't use it, right, as is, right? I wasn't really focused on the artistic aspect. So we are blurring that. We are doing auto levels. You can see the difference, right? Like this is a bit gray here. The auto levels brings it so that it's from 0 to 1, right? It utilizes the whole grayscale range. Then we start warping. We start with like the large. No, we crashed. Okay, I think the stream is back up. I don't know where it cut off. I was just explaining what we did before, so hopefully it's still on. So yeah, we are doing this blurring, auto leveling it, bringing it back to the whole range of the grayscale value of the 0 to 1. Then we start doing the like large scale distortions, simple bending based on this Berlin noise. So if I turn it off, you see that it's like pretty much the shapes that we scattered. Now it's starting to bend a little bit. Then we are taking a more sort of sharper and more frequent noise, higher frequency noise, and we are creating these sharp transitions using the crystals noise, like this, right? Then I'm doing the same, but with like a really high frequency, or almost like, I would say fairly high frequency crystals noise, which adds even more of these, like, I guess folds or whatever. And yeah, then at the end I'm also like slow blurring it, blending it together with itself, so that it's like sometimes it's very jagged, sometimes it's still fairly smooth, I guess. Adding some really fine detail. I think this is extremely overdone. I'm just gonna tone it down. Stack a little bit. Yeah, that's maybe a bit better. Then I'm doing a bit of a non-uniform blur, so some parts again get blurred. Also, if you get these kinds of artifacts, you just need to increase the sample count, right? What the non-uniform blur does is sort of stacks different blurs over each other. So if you increase the samples here, the transition, the gradients will be much smoother. If you still get this like stair stepping, maybe just hit it with another blur, But I think for our purpose here, for such a small detail, this is fine. Also, like a little bit of stepping here and there will create a bit of like visual interest. It's always a fine artistic choice to see whether it's necessary or not, whether it's too noisy or not, right? Okay, and then we are just blending it, blending this fractal sum, very high detail, high frequency noise, uh, with the result from before, hitting it with a subtle blur at the end, 2%, inverting it so that we actually get a hole, right? But this is maybe optional, or maybe not even recommended, because this would be fine for something like Substance Painter as a substance designer. But in InstaMAT, what you actually want to do is not to invert it, leave it as is, and then use the brush with the height setting set to subtract, right? You're subtracting the height, meaning you're going down, you're going inside, inside the object, right? And but the information that gets subtracted is the white information, not the black information, right? So if I had it inverted, and you would want to use it in asset texturing here in InstaMAT, that wouldn't actually work. So you have to think whether this is going to be for InstaMAT only, in which case maybe don't invert it, or whether it's going to be exported into something else. You might want to also might want to export it with an alpha instead of this like weird white or black part. I think if I'm not mistaken, Substance Painter likes that, right? Like it wants alpha there, or maybe it's okay to just have the black values there as well. I don't remember right now. I think it actually handles both. Right, and so what we need in the end is just to expose some outputs. So I'm just gonna say normal in case we wanted a normal. And now we can see we have something, right? Here in the preview. So it's a hole. It's not great, but it's a hole. We can also say height. Yeah, and now we have it. So maybe if we take this height to normal and like lower the crazy normals, it's maybe a bit, well, a bit more sane. I hate this. It always happens to me. So let me turn on the auto exposure. Yeah, so that's it. And I think this is where I stop. I haven't streamed in half a year or something like that. I wanted to start again. Obviously, this was very much unprepared, and I've been trying to force myself to start streaming again for a couple of months now, actually. And I was busy working on my products and my portfolio. Again, if it would be great if you checked out my granges on my Gumroad, as I showed at the beginning of the stream. But of course, I'm not a YouTube schmo to just sell my products or anything. It's a bunch of granges that you can use in InstaMAT and outside of InstaMAT, of course. And yeah, I think I'll be back with something a bit more prepared. Maybe if you let me know what you're interested in. I imagine a lot of people are interested in layering. I actually don't really like it in InstaMAT. I think it's great, but it doesn't fit my needs. Yeah, I just keep running into dead ends, but that's just me. I have a very specific workflow there, and I have very specific needs for like hard surface modeling, and yeah, InstaMAT seems to be throwing some like bricks my way sometimes. But for this procedural stuff, InstaMAT is the shit, right? It's the best of the best right now. I don't think I think it's a really good competitor, if not by far the best competitor out there for procedural stuff. So procedural texturing and stuff like that, procedural material creation. So you can definitely ask questions, tell me what you're interested in, and I'll try to do something here and there. I'm obviously a bit busy here, of course, doing real life stuff, but yeah, I can always come up with something like this. All right, I'm getting tired. I'm rambling, babbling, ranting. So I'm gonna wish you a good night. Play my outro loop. Let's see if that works. Oh yeah, that's it. So, bye bye. Thank you.